Hello. I thought it would be helpful for me to maybe do a video to explain how to do some of the problems that were on the study guide. So I'm going to go through and do that. Hopefully it'll be helpful for you. I'm going to start off with the first two sections, which are on ratios, and I'm going to do these together. So you'll see on the paper that it talks a bit about ratios. We learned that ratios are ways of comparing things, similar to fractions in some ways, but different in others. We talked a lot about how ratios can be used to compare two parts of something or compare a part to a whole. So you'll see there's some examples there. So let's work on the problem that's listed for students to solve. It says, if the ratio of spoiled fruit to non-spoiled fruit in the fruit basket is 5:20, then what are some facts that would come from that? So the first thing we'd want to think about is, what is the ratio that they're giving us? And they're telling us that the ratio is 5:20. And this 5 is spoiled fruit, which might be, I guess, rotten fruit or bruised or something non-edible fruit, compared with 20 pieces of fruit that are not spoiled. So these are not spoiled. So we would call this a part-to-part ratio because we're talking about one part of the whole and the other part of the whole, and we're comparing those to each other. So the first question says, what fraction of the fruit is spoiled? So the first question you'd want to think about, or first thing to think about, is how many pieces of fruit are there altogether? Well, if I have spoiled fruit and non-spoiled fruit, I need to think of them together as how much there is altogether. They're spoiled and non-spoiled, so altogether there's 25. So if the question says, what fraction of the fruit is spoiled, we would say 5 out of 25 is spoiled. We could simplify that if you would like to. If you divide the top by 5 and the bottom by 5, we would get 1/5. So 1/5 of the fruit is spoiled. Convert this to a decimal. We learned that to convert fractions to decimals, it's convenient to convert them to fractions that have a denominator of 100 or 10. So we could do that a couple different ways. One way here is we could do, since it's 5/25, we could multiply the bottom times 4. That would make 100. And if we do the same thing to the top, which we need to do in order to keep these fractions equivalent, 25 times 4 is 100, 5 times 4 is 20. So as a decimal, that would be 20 hundredths. Could also do 5 times 2 is 10, 1 times 2 is 2. So it would also be 2/10. And then the final part says is converting it to a percent. We learned that percent means per 100 or out of 100. So if I could look at these and see, I already have this fraction out of 100. So it looks like this. So that would also be 20%. So if I look back at my different answers here, I could use these or the ones I changed them to as the answers for the first part. Then it says what fraction of the fruit is not spoiled? Well, there's still 25. So this is not spoiled. I still have 25. This time 20 out of 25 is not spoiled. So I could simplify that. If I divide by 5, 4/5 is not spoiled. Again, it says convert this to a decimal. So I could think about making it into a fraction out of 100 or a fraction out of 10, tenths or hundredths. 25 times 4 is 100. 20 times 4 is 80. So that would be 80 hundredths. Or I could do this one, times 2 times 2, 8/10, which would look like this. Either of those would work as a decimal. Then it says percent. Percent means out of 100. We already have this out of hundredths, so it would be 80%. So again, we go back. We can circle these as answers. We could use the reduced versions as well. The final question says, what is the ratio of spoiled fruit to total fruit in the basket? So we talked a lot about how ratios work. This would be comparing part to a whole. So if I looked at that, spoiled fruit, do that up here, is 20, and the whole basket together is 25. So we could do a ratio of 20 to 25. That would be the ratio of spoiled fruit to the total fruit in the basket. The next section that was on ratios is similar, working with ratios, comparing parts to whole. You'll see there's an example there about planting pumpkins that helps explain kind of how you might find the unit rate. So let's work out the problem that students have to solve. Let me erase this. Here we're looking at the Krusty Pizza Company, and they're testing out some new pizza ovens. And it says during 1 hour, 20 pizzas are put into the ovens, and 2 got burned so badly that they couldn't be sold. So the question asks, what is the ratio of pizzas burned to the total pizzas put in the oven? So if I look at this, pizzas burned to total pizzas in the oven. So this is a different ratio than the one we looked at before with the spoiled and unspoiled fruit. This is a part to whole ratio. We're comparing part to the whole. So the pizzas burned are part of the total pizzas in the oven, but this also includes the pizzas that are not burned. So it's not a part to part where we have to find the total. We're given the total and we're given one part, so we may have to figure out what the other part is. So if I filled in the numbers here, we have 2 pizzas burned for every 20 that go in the oven. So if we were going to write that as a ratio of pizzas burned to total in the oven, it would look like this, 2 to 20. The next question says, what is the unit rate for burned pizzas? We talked about unit rate. The unit rate is the rate per 1. So we call it the unit rate. And oftentimes we're given ratios like this, and what we really want to know is how much per 1 or for every 1. We talked about in class, like we want to know how much money does it cost for 1 gallon of gas? How much does it cost for 1 item? If you can get, 5 for $1, how much would 1 cost? So we said that the unit rate is something that we like to find. So for here we want to find the unit rate. So this would be the rate per 1 pizza. So if I want to make this into 1, I could divide by 2. That's how I could get the number of pizzas burned to 1, or cut it in half. That means I need to do the same thing to this side to find what the ratio would be. So if I divide this by 2, it would be 10. So the unit rate for pizzas is 1 to 10, or 10 to 1. 10 pizzas for every 1 that's burned. So that would be the unit rate. Yep. So then if we took that unit rate, we can fill that in those blanks down below. It says for every 10 pizzas that are put in the oven, 1 burns. 10 pizzas are put in the oven for every 1 that is burned. That's 10 pizzas per burned 1. So those are all different ways of saying unit rate. Then the last question says, if this ratio continues, how many pizzas will be burned during 5 hours? Well, the question says up here, this was 1 hour. 2 pizzas are burned for every 20 that go in the oven. So if we were doing it for 5 hours, that would be 100 pizzas put in the oven, and 10 pizzas would be burned. So it'd be 100 to 10. So if this rate continues, how many pizzas will be burned during 5 hours? It would be 10 pizzas. 10 pizzas would be burned. So again, ratios, we talked about ratios. The important thing to think about is, what is the ratio asking or talking about? Is it a part to part? Is it a part to whole? Which number comes first? Which number comes second? All those are important in making sure that the ratio that students write matches the ratio that they're being asked to write. So I hope that's helpful.